Hello, Assalamu alaikum students. Let us study circular convolution. Circular convolution is actually the convolution of periodic signals. Okay, the previous one, the normal convolution that we studied, that was for non-periodic signals, but when we convolve periodic signals, we call that convolution as circular convolution. So formally we can define it like this, that if the convolving sequences are periodic, the convolution is performed only on the fundamental period and it is referred to as periodic or circular convolution. Okay, so 2 points to note, that the sequences that we are using in this convolution will be periodic and the convolution will be performed only on fundamental period, means it will be performed only on one period and it will not repeat. Okay, and mathematically we can write, if we have two sequences as usual, xk and hk, and they both have the fundamental period of k naught, they have equal means equal length of the period. Means the fundamental period is same for both and it is represented with k naught, then we can write circular convolution like this. So this is the standard way as you saw before. The only thing is the symbol is different. This one with the circle around the steric is used for circular convolution. Okay, and for the normal one there is just the steric. Okay, and this notation, as you are much familiar with this, it is the convolution sum, and this notation is for the period, fundamental period, that m starts and ends, or it swipes, or it completes its range that is equal to the fundamental period of both of these sequences. Okay, now let us look at it graphically, how we do. So first thing is, we draw two concentric circles, this inner one and this dotted outer one. On the inner one we lay down the samples of the signal that is, or the sequence that we that is static, that we do not intend to shift, like in our case it is xk. So we start laying down samples from the right side, okay, in clockwise direction. Okay, so sample number 0, then first and second and third, and then so on. But on the outer circle we lay down the samples of the sequence that is supposed to shift, right? Like in our case it is hk, and we lay it down in counterclockwise direction, or it is flipped, right? You remember that we do flipping of the sequence that we shift, like in the previous case. So instead of laying down in clockwise direction, we are laying down in counterclockwise direction, which also represents flipping in comparison with xk. Okay, now we start with multiplying all the corresponding sequence samples here. Okay, like this one multiplies with this, and then this one multiplies with this one multiplies with this, and all these pairs are multiplied and then summed up together. After that we rotate the outer circle by one sample in clockwise direction, like this. Now the new combination, or the new pairs, they are multiplied and then at the end summed up together. Okay, now let us do an example, and that will further help you understanding how it is. Okay, now consider that we have these two sequences, one is xk and the other one is represented with hk. We want to find out their circular convolution. Okay, so therefore, in order to find out their circular convolution, okay, now note that their fundamental period is 4. Okay, it starts from here, ends here, starts from here, ends here, and after that it will start to repeat itself, means that the next sample will be 1 and then 2, then -1 and 3. It keeps on repeating itself after this, and same is the case for h. Okay, so here in curly brackets we are representing only one, or the fundamental period of the signal or the sequence. Okay, so now this is the convolution and this is the result of that we will list down here. Now we will draw exactly the same way. We will draw two concentric circles like this. On the inner one we will lay down the samples of x, and on the outer one we will lay down the samples of, or we will map the samples of h. Okay, so in the first position, we multiply all of these pairs, 0 by 1, 0 by 2, -1 by -1, and 1 with 3, like this. Okay, once we have all of these products, we add them together and we get our first sample of the output sequence, okay, or the convoluted sequence. Now what is our next task? It is to rotate, right? So rotating the outer one in clockwise direction, like this. Now we multiply them again with the new pairs are multiplied and listed like this. Okay, so each of them are multiplied and then listed like this. We add them together, we get our second sample for the output sequence. Now we repeat it again, okay, and we get our next sample, okay, and then we repeat once more and we get our final sample. This is final because after that, if we rotate it further, like now, it exactly becomes like the first one. Okay, so we do not need to repeat it. We will do it only on the fundamental period that has a length of 4. Now our output sequence will also have the same period, and that is of 4 samples, right? So if we do it again, it will continue to repeat itself. The next sample will be 4, then -2, then 3, and -3. So there is no need of repeating it. Okay, so once it is done, we can represent our sample in this form. So this is not the sample, sorry, the output sequence. So yk is the output sequence. It is equal to 4, -2, 3, and -3. This is one way of doing it, but it is a bit it is not very convenient to draw, right? So instead of drawing it like this, we have another method that is called as matrix method that I will show you later in the slide. But now let's do another example. Okay, so in this example, we are asked to find out the convolution of periodic extension of two sequences. One is this one and the other is this one, so that yn is periodic with the fundamental period n is equal to 4. So we are going to convolve these two sequences, and this is the representation of it. Now, instead of drawing those concentric circles, we can write them down in a table. So this will be, since we know that our output sequence will also have the same fundamental period as our sequences, like in this case 4. So we will have the sample 0, sample number 1, sample number 2, and 3. So these accumulatively form 4 samples, right? So our output will also be of 4 samples. Now we will write our sample, our first sequence xn in the normal form, right? 1, 2, 0, and -1. 1, 2, 0, and -1. Now we will write our next shifted one. So shifted version of x. We can write it like this. Now you can see that it is not really shifted, right? It is not really shifted, but it is actually circled the last sample to the first one. So it is exactly the same, but the last one has moved to the first position and the rest are pushed to the further sample positions. Now we will continue doing that the last one will be moved to the first and the others will be pushed to the right. Okay, so we'll keep on doing until we arrive at the last sample, and after that it will come back to its original position, right? So we will leave before that. Okay, once our cycle is completed, then we will leave until means we will leave circulating the samples. So after that we will start to multiply the product. The multiplication will start. Multiplication with hn. So first is multiplying the first row with the first sample. Okay, the first sample is h of 0, right? So we'll multiply this first row with 1, so it will remain the same, right? Then we go to the next one. Our next sample will be multiplied with the second row, h1 with x and -1. Okay, So it will be multiplied with this one, and since it is 3, this will be our multiplication result. So minus 3, 3, 6 and 0. So the next one and then the last one. Okay, now after that we will do add them together. Okay, and we will add only the products, the values of the products starting from here until here. Okay, we will disregard the top layers now or top rows now. Okay, we will have to add only the product terms. Okay, so we add them together and we get this answer. Okay, exactly the same as in the previous case. Okay, as in our previous example. Okay, you will get the same answer graphically or non-graphically in the table form. Okay, so the graphically is a bit for means difficult to draw, and then spin the circle, and then it is a bit difficult to do it manually, but this is a bit simpler way than that. Okay, so it's up to you whichever you want to use. There is another one that I will show you also. Now you do the same example with matrix method. Okay, now we can draw a matrix. Okay, we have this xn and hn as usual. We first we write xn in the matrix. Okay, we draw brackets. Okay, and this whole of the sequence will be aligned in one column. Okay, so means that it will have 4 rows because it has 4 samples. First row first sample, second row second sample, third row third sample, and fourth row fourth sample. We will lay it down like this. Okay, and then we'll start to rotate its samples. Okay, now -2 will go up, and then all of these 3 will be shifted down like this. Now -1 will go up and these 3 will be shifted down, and then 3 will go up and others will be shifted down, right? So now the circulation of the signals samples is completed. If we do once more, we will get our first column back again. Okay, and we do not want that. We will keep ourselves to one fundamental period only. Okay, now we have to write hn, okay, in the matrix form, and we'll write it like this in the straight form. Okay, we are not shifting it or not flipping it. We write exactly like this. Okay, now we can perform matrix multiplication, and you know how we do it. We simply multiply this one, the rows with the column, right? Simply multiply rows with a column, then next one, then next one, and then next one, like this. Okay, this one is multiplied with 1. Okay, this whole first row is multiplied with the first element here, and then second one with the second one, and then third one with the third element, fourth with the fourth element. Okay, so once we do that, we complete it, we get this answer. Okay, so the first element in the row, then second element in the row, third element in the row, and fourth element in the row, right? So this is our output. This is our yn. You can write it like this. Okay, so very simple, right? So that is the end of it. I hope you understand it. There is nothing complicated in it, and it will be much easier now with all the understanding that you have about the convolution. Thank you very much. If you have any questions, you can discuss with me later. Thank you.